Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Welcome to guest lecture of the Agricultural and Biosystem Engineering. This guest lecture with the title of Advanced Technology in Agriculture, Measurement Technology and Agricultural Robotic. First of all, let me introduce myself. I'm Vela Seviana, student from Agricultural and Biosystem Engineering, Universitas Gadjah Mada, will be today's event MC. This event is part of a weekly series of workshops that are held twice a week to be a part of implementation of independent campus competition program with agricultural and biosystem engineering partners. Therefore, we will get to know more about agricultural technology and gaining various benefits. So don't miss out on participating in every series of this workshop. Sebelum memulai rangkaian acara kuliah tamu ini, izinkan saya untuk menyampaikan beberapa tata tertib yang harus dipatuhi sepanjang kegiatan ini berlangsung. Pertama, peserta diwajibkan hadir 10 menit sebelum acara dimulai, yakni pukul 12:50 waktu Indonesia Barat. Kedua, peserta wajib menggunakan format penamaan instansi _ nama lengkap. Untuk mengubah format penamaan tersebut, Anda dapat menekan tombol di pojok kanan atas pada participant list, kemudian tekan More, lalu tekan Rename, dan isikan sesuai format yang diinginkan. Ketiga, peserta diharapkan menggunakan virtual background yang telah disediakan oleh panitia selama sesi workshop berlangsung. Virtual background ini dapat diakses melalui link yang akan disampaikan oleh panitia melalui kolom chat room Zoom atau pada link yang sudah dibagikan pada grup WhatsApp. Keempat, peserta diharapkan untuk mengaktifkan video selama sesi workshop berlangsung. Kelima, peserta wajib menonaktifkan suara selama sesi workshop berlangsung, kecuali memperoleh izin dari moderator atau panitia PKKM. Keenam, peserta yang mengalami kendala selama kegiatan berlangsung dapat menghubungi panitia melalui private chat. Ketujuh, peserta diharapkan berpakaian dan berperilaku sopan selama sesi workshop. Kedelapan, peserta dapat menyampaikan pertanyaan melalui kolom chat atau secara langsung melalui mikrofon setelah dipersilakan oleh moderator. Kesembilan, dimohon bagi para peserta untuk dapat mengisi presensi kehadiran melalui tautan yang akan disediakan ketika sesi berlangsung. Lalu yang terakhir, informasi seri selanjutnya workshop PKKM dapat dilihat pada akun Instagram kami yakni @tpb.ugm serta akun Facebook atau Twitter @tpbugm. Diharapkan seluruh peserta mematuhi tata tertib yang ada supaya kuliah tamu dapat berjalan dengan lancar. In this afternoon, we will discuss together with Dr. Suhadarian Mora from SIIT, Thammasat University, Thailand, and Mr. Seong-Shi Han, PhD, from Gangwon National University, South Korea. We will start this discussion with our moderator. He is Mr. Makbul Hajat, STPM Engineering PhD, that will be introduced from this curriculum vitae. Bapak Makbul Hajat PhD, Department of Agricultural and Biosystem Engineering, Pendidikan S1 Teknik Pertanian Universitas Gadjah Mada, S2 Manufacturing System and Mechanical Engineering, SIIT Thammasat University, S3 Industrial and Manufacturing System Engineering, King Mongkut's University of Technology, Thonbun. Penelitian, rancang bangun dan optimasi alat separator biji-bijian skala laboratorium untuk meningkatkan kebersihan dan keseragaman produk. Kemudian ada optimasi proses pengolahan limbah akar hidroponik menjadi arang aktif menggunakan teknologi pirolisis. Kemudian ada pengembangan kawasan pedesaan Margo Marem Wonosobo. Kemudian ada peningkatan pendapatan petani dengan penerapan sistem pertanian terpadu lanjutan, studi pendahuluan penyusunan master plan smart farming berbasis korporasi. Dan yang terakhir ada pengembangan prototipe tunggal dalam di Blora dan Grobogan. Okay, without delaying time, let's start the discussion this afternoon with Mr. Makbul.
Okay, before everything, I want to check if my voice is normal. It's okay. Okay. Thank you so much, Miss Bella, for the time lecture held by Department of Agriculture and by System Engineering as part of PKKM program or Program Kompetisi Kampus Merdeka under management of Directorate General of Higher Education, the Ministry of Education, Culture, Research and Technology Indonesia. And this is the 6th International Guest Lecture. And in the next coming week, we will have some more interesting international guest lecture topic. You may refer to our social media to get more information about this agenda. Instagram at tpb.ugm or our YouTube channel at Teknik Pertanian and Biosystem UGM. Well, today we will continue to learn the topic related to agricultural engineering topic. Then here we go. Let me introduce to you our speakers for this afternoon. The first lecture is from Sirindan International Institute of Technology, Thammasat University, Assistant Professor Dr. Suchada Rianmora. Hello, Dr. Suchada. Usually I call her Achanchum.
Hi.
Good afternoon.
สวัสดีค่ะ in Thai.
สวัสดีครับ
Yeah. Good afternoon, everybody. Do
How are
hear
you
me?
there, Dr. Suchada?
Yes. I'm not sure that you hear my voice clearly.
Yes,
Yeah, okay.
we hear your voice very clear.
Okay. Thank you so much.
Yeah, I hope you and family are in good health. We wish
COVID time.
we wish next time to invite you physically here in Yogyakarta.
Okay.
Maybe
I would love to
next-
visit your place next time. Thank you so
Yes.
much.
Thank you so much. And the second guest lecture is from South Korea, Gangwon National University. He is Mr. Song Ji Han, PhD. Hello, Mr. Han.
Hello, hello.
How are you there?
I'm great. I'm great. Thanks for
Hey,
your invitation.
Nice to meet you.
Nice to meet you.
Okay, just for your information, first session will be a lecture session. You will be given 40 minutes to deliver the lecture. We will start with Dr. Suchada first and then continue with Dr. Han. Then next is the discussion session about the topic. Okay, first we will be hearing a lecture from Dr. Suchada first about measurement and instrumentation for food processing. But before going so far, I will show you some information about Dr. Suchada. Let me read it for you through this slide. Well, her name is Dr. Suchada Rianmora. Education background is bachelor degree in industrial engineering from Sirindan International Institute of Technology, Thammasat University, Thailand. Her master engineering in industrial production technology from Kasasat University, and doctoral engineering in design and manufacturing engineering, ASEAN Institute of Technology, Thailand. Okay, her area of expertise is in reverse engineering, application of image processing in manufacturing process, product design and development, and design for manufacturing, and also some CAD/CAM software. Okay, that's all for the information about Dr. Suchada. Where Dr. Suchada, you will have about 40 minutes to deliver your lecture, and I will remind you later if you have 3 minutes left. Well, stage and times are yours.
Okay. Thank you so much. I will share the screen. Did you see this?
Okay.
Okay. Can I start?
Yes, yeah, you may start.
Hello, my name is Suchada Rianmora. My place is at School of Manufacturing System and Mechanical Engineering at Sinindon International Institute of Technology, Thammasat University, Thailand. You can visit me via this website or email address. Before going to detail of this topic, instruments and measurement technology for food products, I really want to show you something about my place. I am here, my workplace is here around Pathum Thani, Thailand. You can search SIIT from the website and you will see this picture. For more detail, I really want to show you something about Thailand. You have so many places to visit off the boundary here, so many interesting places. And then very interesting in the Glen Palace here in Bangkok, it's center of the Thailand. And now, before going to detail of the topic, I would like to tell you about the outline to be the road trip. Let's start the first position. First position is about what is food. After we discuss about this for a while, we will start with the next location, which is customer perceptions. We're trying to translate customer needs and understand well about the technology besides. Next, position number 3, we talk about foods and in technologies. Next station, I would like to start with tools and equipment, how to apply this thing to the food industry. And next, we're trying to talk about examples and case study. After we know the case study that I have done before, I will guide you about how to select the appropriate tools. Finally, the last station, I would like to make a conclusion for you with a very clear detail. I've used 30 seconds magic time for letting myself explaining about each topic. You will enjoy with this one. First location, what is food? I will try to explain to you briefly about the guideline and the meaning of food. Let's start the key point. The meaning of food in your opinion and about the types. Let's start with this one. What do you think when you think about the food? In this new world, we always search everything by using Google platform, right? You just put the keyword here. Like this case, my food is about this thing. What do you think? This is yes or no. This is the real food. Moreover, the plant sorts and the animal sorts are the key consideration for making foods. The station number 2, customer perceptions. Actually, this one will be talk about what customer wants and needs. For the second station, various types of foods. Have you ever seen this kind of picture before? Trying to bring the old day of yours, try to bring your experiences, different cultures, you have different food styles. What do you think? Various style of tools is applied. See, you have so many tools for making or cooking, right? And how about the equipment? If you want to make just like the cook, you may think about ingredients, how to combine them together by using instruments or process. Like this case, customer behavior or consumer behavior. You have to think about how the people think about the food and tools. Risk perception is one of that key consideration. Communication, and next, nutrition and health. Moreover, the last one, emotional or sensory science are taken into considerations about consumer behavior. The key point, you please try to think about influencers, societies, cultures, and the last one, experiences are very important key component for finding tools. The next one, if you want to scope down the meaning of customer or consumer behavior, you may use all of these keywords and search. For this case, I would like to scope down for you. If you want to select the right tool, you have to understand ages, hobbies, or even target customers. you will see what they really want from you. First thing, try to translate the needs. Second one, understand satisfaction. Next, try to create the design. And last one, get the feedback. For all of that, will be help you a lot for identifying tools versus food industries. The next station, foods and technologies. How to link between these two, it is very interesting topics because right now we have a lot of information, just like this case, digital world. Did you see that? We always order something from the internet or mobile. The right-hand side are about eco world. Can you compare between these two? For the eco world, we would like to get fresh food, nice and clean food. How to do? No worries, I will tell you in minutes. Trying to think about your perception. Have you ever seen this kind of food before? Different style of foods, you have to apply different technique for making food or completely making dinner, lunch, or even breakfast. All of this will help you for this case study. Have you ever seen this thing before? I would like to share the case study for making noodle. How to make? We have various styles. Maybe you can smell from this picture, right? Look very great. Try to bring the all day, try to bring your perception and experiences and tell me about the technology applied. For the first case, technologies, we may consider handmade or homemade one with classic style, making noodle. How to do? These kind of activities are starting with raw material. We trying to bring flour, eggs, or even our hands, like the tools. In this case, we use the stick, see that, for forming the shape of the raw material of the noodles. We use the knife for cutting the noodles into pieces. Of this, you see that this is a finished part or finished product. Technologies. Right now, if you want to produce everything in mass production, manufacturing process is introduced. Like this case, I will try to show you just some example about manufacturing process to make by using extrusion process or deformation one. The two concepts. This one, extrusion. See, we can get different sizes, different shape from the mold. The benefit, first one, fast process, mass production, and last one, uniform size. You can see from this point, see, comparing to the traditional one, this one is pretty fast. You get uniform layer thickness. Moreover, in case that you want to apply everything like this at home, we can use ETCU machine. Put the ingredients on the top, and then you will get the desired shape you want. This is called very convenient concept. The next station, tools and equipment. What is the tools for the food industries? Big concepts, food products versus technologies. The technologies here will be explained. For the tools, we may think about this one, right? In engineering viewpoint, we apply entire thing here for making the process of products. However, how about in food industries? What do you think? For the food products, can you guess what are the tools applied? Can you imagine that? The answer is what? What do you think? Spoon, fork, and knife are the tools, right? How about this thing? For eating pizza, I think This one may be the hand, right? To use the hand as the tools. Yes, it is. Moreover, how about this thing? You see the action inside this animation? The answer is yes, chopstick is the key component or the tools. Did you see the guideline? Moreover, in advanced technology, I would like to review something for you for the classic style and tones of the tools. Tool story with the remote control. On your left-hand side, it is about smart remote control. You control everything by using mobile phone or Internet of Things. Comparing to the right-hand side one, it is a traditional remote control. I have it at home. You can control everything just pressing, right? The tips controlling system consists of this kind of picture. Can you see? We use controlling system for everyday life activities like this animation. The concepts are input, process, and output. The inputs are about switches. The main board is the process, and the output may be the action that we really want. For more detail, you can see the example of the devices here. For the input, the controller for the process, and the outputs are maybe about like motor or light. Thank you for the website. Next, tips about the components of controlling system. Images about camera, computer, and printer. These three things are considered as a controlling system too. You see the guideline for this case? How about food industry? This is the mold, making jelly size. See, raw material is pressed to form the shape according to the mold cavity. In this case too, we use technology like robots for making the screen. How about this? We use filling operation for filling the liquid inside by using motor for moving the mechanism. Moreover, the sensor is applied for leveling water inside a bottle. See that? Everything related to controlling system, including food industries. Text and tools. For about the sensor, please consider this animation. See that 100% of the brightness may be energized when the people pass by, and 30% brightness is there when nobody's there. We can try to use the sensor too. This placement sensor. See? This placement sensor, we use it for gap measurement, the height measurement, or even distance between two objects. This placement sensor is very interesting thing for industries. Next case study about a sensor. Soil moisture sensor. See? Resistance is the key point for this equipment. Maximum and minimum will tell some story about the amount of the water inside the soil. The minimum one, the maximum water. This one is non-contact, right? No, it is not non-contact. And how about this one? Yes, this one is non-contact with reflective methods. We use the sensor or even the displacement sensor to send a signal and receive the thing back after hitting the target. Do you see the guideline for this? And now, I think we can move faster to the example of the sensor like smart gardens. I saw this thing from the website, very interesting. We call like the app control. Features on app can control the light, and then the schedule can be made. Automatic watering is applied. You see from the screen, see that we can make the schedule for lighting or in watering. Very easy. You can use this thing for decorating your home or even kitchen. Pretty nice. The function inside, you just touch this bar. the light is turned on and off automatically. This one, I can consider it as the smart lighting platform. See, very nice one. Moreover, the sensor can be applied for more in smart garden to avoid overwatering and underwatering. What are they? Please consider your right-hand side here. We use the same concept of soil moisture sensor. Minimum and maximum value of the resistance are the key points. See, this is the real world case. We plug this thing inside the soil, and then the signal will be passed through on the top. You will see the condition of the water inside the soil. For the detail, I will tell you like this key components. Resistance is the key point. First one, the soil moisture sensor is applied where the fork-shaped probe. Did you see? The fork-shaped probe is here, it's plugged inside the soil. And then it works just like potentiometer. What is this? No worries, I provide a picture for you. Potentiometer is here, is about adjusting something like you turning or tuning the radio volume. The potentiometer is about the resistor that you can slide or rotating for forming adjustable voltage divider. Like this case, the voltage value can be varied. For more detail, you can see from this thing, you turn this thing maybe in 360 degrees slowly. The value on the screen is changed. This one very useful. For the conclusion for this, the resistance is inversely proportional to the soil moisture. More water in the soil means better conductivity and result in lower resistance. In contrast, low water in the soil means poor conductivity will result in higher resistance. You see from this graphical design, see? Minimum resistance, maximum water. How to connect and combine this thing to the real world. Did you see? 4 components are applied for this soil moisture sensor. AO, analog output, DO, digital output. Next, VCC for supplier, and then the ground. These are the components of the soil moisture sensor that we need. If we want to connect the sensor to the board or the processing controller, you see, we can connect to this board as Arduino one. You can search this keyword for finding the real applications. Rain sensor is very interesting sensor. The same concept as before. Did you see? The rains drop down on the platform and then the water can be measured by using resistance. See? The same concept as before. On your right-hand side are the components available in the market. You can search by using rain sensor. You can see these products. Moreover, I'll be trying to hint you some long story of the raindrop sensor. Just consider only the highlight color. This sensor is very smart and low cost. The components are about a rain sensing pad and controlling board. For the rest, you may see this information inside description of the raindrop sensor from the internet or the articles. Station number 5, examples plus case studies that I have done recently. How to link technology to the food. I will show you next. Trying to translate perception to the design. Trying to bring perceptions and record it as experiences. This one, salad, combines so many fruits and vegetables. However, how to clean vegetables and fruits? See that? The water left on the surface. I found very interesting articles or even the available markets. You see, salad spinner. We're trying to remove the water out of the vegetable, and then we can prepare the food inside the bowl. Very convenient, right? However, I found the errors at the bottom base. We need something called anti-slip surface is required to hold the bowl while spinning in place. So I will try to start by using this concept for making tools by translating customer needs. First thing, I may start with launching the questionnaire to ask the people about their perception and opinion. And then I extract them into categories of characteristics by using adjective word plus definition. See that? All of these are the adjective words, like the round shape, salad spinner has a round shape, or even the pushing by applying force. All of this come from questionnaire, including emotional from the customers too. See? Definition and the customer emotional are extracted into this platform. Now, we're trying to use very nice concept called Kaiser-Meyer eigen and ballot taste for translating customer feeling to be numbers. You see from this result? This number will tell us some story about the number of parameters applied. This kind of significant factors. We tell you about the story of the design in conceptual process. You may see from this picture, more like on your left-hand side and the more like on your right-hand side are just totally different in meaning with different sign, plus and minus form. See? Minus here is about classic tone and the plus here is the modern one. You can guess? Classic appearance and the modern appearance. At the neutral value as 0. We apply this concept for translating design to be numbers. From this point, we also use rotating component matrix. You can search this thing from the internet for finding the method to use where the eigenvalue should be more than 1. This is the point. The graph eigenvalue here should be considered around 1 and above 1. You see the number of component 1, 2, and 3. The number of the component here is about the number of designs. You may consider this thing 3 groups because the number of 3 more than 1 from the eigenvalue. See, 3 components. For the first group of the design, plus value means you consider positive value, which is modern. Plus value here consider about the plastic one in the positive zone. And minus here consider about round shape in negative form. You see the guideline? And next, all of this are compared between customer requirements and product specification in engineering viewpoint. I got 3 designs from the eigenvalue. See that? And then customer requirement is modern form, whereas engineering viewpoints are talk about plastic and shape. We make classification of the salad spinner by using components and the subcomponents. For the final products, after we try to translate customer needs, we get the design of the new design of the salad spinner. Did you see? We try to make the corner like 90-degree shape for fitting the products to every corner inside the kitchen. This is the prototype from rapid prototyping process. See the guideline for this case? These are the research from this team. For the next one, how to apply and link foods and technologies. On your left-hand side are about the food, whereas on your right-hand side are about technology applied for making that food. In detail, I will make the case study for you. Please consider these key considerations. This is the fish. How to link the fish to technology or the concept applied. On your right-hand side are about fishing theory. We try to consider the angle and the force applied during fishing. See, some researchers have tried to combine and consider force and angle. Force increase with angle. You see the line? And then the conclusion, they make this kind of result. The angle and the force are obtained. You will get a fresh food to eat, nice quality of the fish. For the next example, what is this in Thai called tom yam goong, or it is like the shrimp soup? From your perception, how to cook? Yes, you may use heat transfer. This one, we use the fire, and to make the soup here, maybe need some equipment like the pot, and you have to stir by using the tools. See, in different cultures, you need the heat to cook. Am I right? Even in this case, instant noodle, you still need the heat for cooking, right? The key point, the heat that we want. And how to apply the heat and the concept inside this one. Please consider this key point. Did you see? We have the fire here. We have the container or the pan and the handle. See it carefully. Fire, pan, and handle. The concept of this one, we have three keywords: convection, conduction, and radiation. For convection is about transfer heat inside the liquid form, inside the container. Conduction is about transfer, about the heat one substance to another. And the radiation is from fire. I give you so many pictures from CD guideline. See? Convection, conduction, and radiation are the key considerations in this case. We also consider about the simulations. I have found this one from the article. They try to play with about heat transfer simulation methods. Moreover, in concept like paperwork, they're trying to use 3 formulas for explaining about each. How about the cold room? Do you see? Instead of playing about the hot thing, we play about the cold thing. For the logistics supply chain, we have the refrigerated car or truck. We convey with the forklift, and then we stack it up in here and move into the cold room. See that? It's very interesting for saving the material in a good place. See, we have air conditioner here, the stack up of the box, and then different layout will get different temperature inside the box. The real case of the cold room will be explained to you via case study. For the guideline, sensitive products like the fresh food, how to preserve this one in a good condition? The answer is we have to understand about the temperature inside the room and the velocity of the air inside the room. See, these are the simulations applied. Whereas at the middle, you see the black color there. It's about the box or container that contain the fruits. The case study separated in 3 portions, figure 1, 2, and 3, or A, B, and C. 3 considerations, 3 examples are compared in plastic size, total number of crates, number of layers, and also the number of pallets loaded. 3 case studies are studied in this research with different amounts of the kilogram here. You will get different layout. This is the guideline for the layout inside the cold room. See? You see this one, front and the top view, air conditioner on the top, and then we have the box in there, like the crate. And also we locate it on the platform like pallets. The results show some simulations about the velocity and the temperature inside the cold room, where the condition of the aircon is the key point. Thank you for this team for making this thing finish. Next station about guidelines for selecting tools. Did you see the idea? Smart tools versus smart rules. We try to play with the smart device for our farming or IoT platform. It's very interesting in nowadays. How about this thing? You try to grow the plants manually, right? By using your own experiences or perception. Even this one, how to apply the light to the plant. We put next to the window. For the concept of this, watering plants with ring irrigation system. You can put the water directly to the root of the plants. This case study is about ring. See the red color there? It's the ring. You cover the ring by using the condition of moisture sensor, temperature sensor, and light sensor. These three are considered and plugged into the soil. The water is applied here. These are the main components in this research. This is a product. This is the ring, and then you plug the ring into the potted plants. The sensor will show you some value of this one. Moreover, in this case, I may show you something like this. You put the ring in here, and then you can get the water individually for planting. Plug every sensor inside the soil, and then get the results from the screen. With a compact size, you can bring this place to everywhere that you want. From this idea, thank you so much for this too, for helping me to finish this task. Future foods versus how to or to. This platform is very interesting. We talk about the rules. If you want to play with about technology in the food industries, you have to see something inside. First one, you have to translate customer needs, understand the needs of them. Customer needs is about other things that customer requires and purchasing a product or service. What are they? I will try to show you via the animation instead. First one, the key tools. Everything should be formed in the mobile applications, right? Even if you want to get some help. Perception plus experiences come from different careers and background. New life is about delivery thing because the people really want to get easy to access platform. How about this case? This is a new normal style of the people, right? People want to take a picture before eating. This is the new concept of customer needs. For the second one, consumption platform. Consumption here is about try to estimate consumption in terms of customers. You have to understand and estimate the number of potential customers. Second one, the size of your potential target markets. Then identify the target customers. Finally, you have to find the lifestyle and style of the products needed. The next platform is about fulfillment. How to get to this point, easy to access is the key. On your right-hand side are the framework of easy to access, applying API. Applications should be formed in digital form. Each step should be run automatically. Self-fulfillment model. You have to run everything under the same roof, like inventory, ordering thing, or even packaging. And then the customer place and pay the money to you via the mobile application. For the next one, create fast tracks and safety platform for distribution or transportation. You may select the right methods to launch the product to your customers. You may use the shipping one for save your costs. However, I have found this thing from this guideline. In case that you want to create or delivering something like the bottle liquid thing like this with the packaging. During transportation, see, drive along the road, you may see some accidents during transportations. How to prevent this kind of thing? We have to know about the types of the containers, right? The crates and the inserts. Trying to bring the benefit of each to generate the new design of protection. Did you see? This one is applied inside the crates or inside the box for fixing the bottle in place. The simulation is applied in case that we drive the car and then this kind of accidents may be applied according to the force. We plug this thing individually to the bottle. Finally, we have also concerned about the simulation and the force too. Thank you for this too, for making this thing happen. The next, how about production platform? Please try to select the right thing to the right source and reasonable price. Like this one for the mass production. Pancake flipper is applied for producing 1,000 units, or even Pop-Tarts. Instead of using manual mode, you can use automatic one. Moreover, like these technologies, we apply a lot of divisions, right? You just bring the right place to the right location. From this raw material, you have to bring very good ingredients to make a very nice product. The next one, raw materials. Yes, we are talking about primary industry, farming, fresh food. We may talk about mining, mineral resources, fishing, or even agricultural. Like this image. You see the guideline for primary sector? Actually, we have 3 types of industry: primary, secondary, and tertiary one. Primary, talking about agricultural, fishing. Manufacturing process is a second choice. And the last one is about service sector, like the doctor or hospital. From this point, raw material, we may focusing on farming or fresh foods. The last step, production design, PDD concept is applied and linked directly to consumer demands. We have to know and understand what customer wants. And how to do, you may set the target first, and then trying to link between the idea from different sources, set the goal, find the methods, and then try to test. The steps are asking, imaging, planning, creating the idea, and the last one is about testing. Internet of Things is one of example in today's competitive markets. I will try to tell you about the case study in food industries, like sensor, drone, and 3D printing. Let's start. The first one, drones versus foods. I have found this thing from this article. They play about the drone and how to change the battery without using human. See, right now we prefer to bring the food to our home by using the drone to save the time. We have to know about the condition of the drone and its applications. And then we have to understand different situations like sunny day, rainy day, or even the weather. Moreover, for this case, it would be nice that we can launch emergency thing from the drone and how to recharge the battery without using humans. This research, they used a case study for this drone type. They're trying to generate these cuts and create the thing based on PDD concepts. Finally, we will get the designs of the parts that we want. For the results, I will show you from these pictures. They have the drone, and then the black one here is the platform of the battery charger. We used automatic mode to remove this battery out. And then by using this robot arm, this one will be plugged into the charger. Once the new battery is recharged, the arm is removed, the battery out, and then finally we try to replace the new battery inside the drone without human. This is a concept. For all of this, it would be nice that we can apply this thing to the real world, like the food industries. These two, thank you so much. For the next application of the sensor, we may play with about automatic filling machine. How to apply the sensor to maybe liquid products. We combine traditional school style with traditional manufacturing process. After we think about the benefit of each, we combine to make our new product. Like this case, we're still using the same housing, but inside we control by using automatic filling mode. No need to wait and fill. Let the machine do it for you according to the conditions that we applied. These are the real application happened. Steps are required for each component. The results show you via the screen. We use the controlling system. Thank you for this one. For the second application of the sensor, we try to save our sensitive products with a good condition. We call it keep it cool bag. You see that this bag is just like traditional bag. We just add extra thing inside by using Internet of Things plus controlling system. We can control everything via mobile application by using the voice control, or we can use our finger, see the location of the bag and also the condition of the bag inside. These are the concept or components applied. For this concept, I think it's very useful for finding the location of the bag. After applying this thing to traditional bag, you would keep everything in a good place, even the medicine or the snack. You can keep it dried without moisture. For this concept can be applied for the food industry too. Thank you for this too, for making this thing happen. We are in the last station, the conclusion one. I would like to conclude everything for you in seconds. For about the concepts of this, please selecting the right tools to the right job. What is this? We are alone. I would like to tell you about this. Really? Yes or no? In my opinion, it is no, we are not alone. But you want to extract the meaning of alone out. I will try to tell you like this. A, area of interest. L, learn new things. O, overwhelm support. And new designs or idea. E, extraordinary. Yes, we are alone. For this point, we are the team. Thank you for these people to make my dreams happen. With different specialists or characteristics, we can generate a new thing. From this point, I would like to thank you this one too. Different categories, different idea, we will generate everything in right direction. For the last set, thank you for this too, for making something like agricultural industry happened. Finally, I want to inform you about good team, good tools, smart rules, full success, well-trained, gain happiness, and finally, will feel impressed, less errors. Thank you so much for joining my presentations, and then hope you guys enjoy this class. Bye.
Okay, thank you so much, Dr. Suchaja, for an eye-catching and well-prepared presentation and lecture. Okay, before going to the next speaker, I have some notes from Dr. Suchaja's presentations, especially about the concept about customer perception or design perspective, and also about the conceptual design method for designing the products, and also some research on sensor technology for agricultural purpose, and many things presented in a very interesting way. Okay, again, thank you so much to Dr. Suchada for the presentations. Let's give an applause or by clicking emoticon reaction on your Zoom screen. Okay, guys, if you have any questions about this topic, you may write it down on the chat room. And next, in the discussion session, we will discuss it with our speaker. Okay, the second lecture, we will be hearing from Dr. Han about another interesting topic. But before going so far, I will show you some information about Dr. Han. Let me read it for you through this slide. Well, Dr. Han, his name is Seong-ji Han, PhD from Gangwon National University, South Korea. And his educational background, bachelor degree at Beijing Union University in electrical engineering, and master degree in biosystem engineering at Seoul National University, and also Doctor of Philosophy also in biosystem engineering at Seoul National University, and also he has postdoctoral research at biological and agriculture engineering at Texas A&M University, and also some research of interest in precision agriculture, remote sensing, agricultural robotic, and agricultural automation, and also about machine vision. Okay, that's all. Some information about Dr. Han. Okay, Dr. Han, you will have 40 minutes to deliver your lecture, and just allow me to remind you later if you have 3 minutes left. Well, Dr. Han, stage and time are yours. Thank you.
Thank you. Thank you. Let me share my screen. Can you see my screen?
Yes, clearly.
Okay. Thank you. Thanks for your invitation to let me have this kind of opportunities to give a lecture about my research. Today, the topic of my presentation is current development of agricultural robotics. But before my presentation, as Dr. Babu introduced, since he has introduced my educational background, I would like to skip this part. And before my presentation, I would like to introduce about my laboratory. The name of my laboratory is Digital Agriculture and Robotics Laboratory. And the mainly research area include the precision agriculture, agricultural robotics, automation and control. As you can see the pictures below, we are doing the research about agricultural robotics. As you can see, this is autonomous tractor. We're also doing the research about the UAV-based remote sensing. And we are also doing the research about AI-based agricultural robotics. The research in our lab included 4 parts. I would like to introduce my research about 4 parts. The first one is the indoor farming and the greenhouse automation. We are also doing the automated and the connected agricultural robotic system. We are also doing the UAV-based remote sensing for field phenotyping And the last one is IoT in agriculture. So the main content, the main topic I want to talk today is the unmanned area systems for precision agriculture and high throughput field phenotyping. Okay, so the first one, I would like to introduce the unmanned area system. Most of us know or have heard about drone or UAV, as mentioned from the Dr. Strada. So what is UAS? Everyone needs to distinguish between the UAV and the UAS. The UAS contains the UAV, ground control, and communication links. The UAV knows the position through the satellite system and use the wireless transmission to transmit the position to the ground control station. The ground control station then transmit the next location, next actions to the UAV according to the UAV's position. So this is the closed loop system. The UAS is composed of 6 parts: unmanned aircraft, communication data link, payload, launch and recovery elements, human elements, and command and control elements. Let me introduce about the UAV. UAV can be operated without the possibility of the direct human intervention from within or on the aircraft. As you can see, these 3 pictures are normally used nowadays for crop monitoring in agriculture. Also, there are some other terms used, include the remotely piloted aerial vehicle or remotely piloted aircraft, but the most of people call it as drone, right? Let me talk about the ground control. This is the ground control station used in the military. And this is the ground control station used for the civilian targets. And this is a research team when I studied in the United States. And this kind of the ground control station enables the UAV monitoring, flight planning, and autonomous operation. This is the example of showing the flight planning. This is the Pix4D flight planning interface. As you can see, we can design the flight path layout. We also can change the flight altitude. Yeah, as you can see, we also get access to the image overlap setting. Here is a video made by the Pix4D company. You guys can see the procedure of the flight planning. video provided from the Body company. And let's see the communication data link. The communication data link consists of an RF transmitter, a receiver, and an antenna. As you can see, these are the mostly used frequencies in the world. And the functions of the communication data link is to uplink from the ground station or satellite to send the control data to UAV, or the downlink from the UAV to send the data from the onboard sensors and the telemetry system to the ground station. And here are some other components. As you can see, these are the launching system, and this is the recovery system when you finish the flight. Also, we can put the camera or LiDAR sensor on the UAV. Here is a quick video for showing the rotary wing UAV takeoff action. As you can see, here is the LiDAR sensor. The LiDAR sensor is still operating to scan the ground condition. Okay, this is the rotary wing UAV. Let me show you the fixed wing UAV. This is the video for showing the launching system for fixed wing UAV. Okay, and let me talk about the sensor payload. Nowadays, most of the researchers put the three kinds of sensors on the UAV. The first one is the RGB camera. The RGB camera can be used to generate the image mosaic and something like structure for motion digital service models. To monitor the crop status, we use the multispectral camera. The multispectral camera can be used to generate RGB and NR mosaic because NR is very useful for the crop health monitoring. Also, we also put the LiDAR sensor for generating the cloud point. There are some other sensors, something like the hyperspectral camera and the thermal sensors. Actually, the hyperspectral camera is more accurate than the multispectral camera. Here are some various criteria used to classify the UAV. We can classify the UAV based on the size, weight, altitude, endurance, type, and range. Here are some combinations of the criteria to create the various classes, something like LALE. It means that the low altitude and the long endurance. For example, of the LASE, it means that the low altitude and the short endurance. So based on the flight time and the flight height information, we can divide into the several UAV classification. For example, for LALE, it means that the low altitude and the long endurance. And for the LASE, it means that the low altitude and the short endurance. Let me compare the rotary and the fixed wing UAVs. The rotary wing UAV consists of the propellers that are spanned by corresponding motors for vertical takeoff and landing. But the fixed wing UAV consists of the rigid wing, similar in design to the airplane. Here is the main components of the rotary wing UAV. As you can see, we have the GPS for location the information for receiving the location information. Here's flight controller to control the aircraft. And we also have the electric speed controller. It can control the speed of the propeller. We also have the telemetry module. It can be used to manage the communication signals. Also, we have some other power board and battery. Yeah, let's see the fixed wing UAV. So fixed wing UAV, we have the servo actuator to control the direction, and we have the motor and the propeller, and we have the flight controller, GPS, radio, speed controller, and the battery as well. So we can use the rotary wing UAV or fixed wing UAV for different applications. Here are some UAS application examples. We can use this UAS for surveying objects on the ground and industrial inspection, aerial images and photography, aerial movies and videography or monitoring. Let me talk about the photogrammetry. What is the photogrammetry? We can divide the word of the photogrammetry into the three parts. Photo. Photo means phot, indicating the light, and the gram is grammar. That means the drawing, and the metry means the metrine, indicating the measurements. So the typical output of the photogrammetry are a map, drawing, measurement, or 3D model. So the photogrammetry draws on diverse concepts from the various disciplines, including the photography, physics, computer vision, and the metrology. Here is the basic photogrammetry principles. This is something kind of the non-contact measurements. It can be accomplished without any physical contact with objects. It can capture the data through the photography. Once we get the 2D image from the camera, and then we can use the photogrammetry solution. After that, we can get the 3D model from the 2D image. Let's see how we can receive or get the image. We can use the close range photogrammetry, something like the camera as shown here. We also can get the image from the tripod, photo satellite, or aerial image, or the satellite image. So we have the different ways to get image. Let's see if there are any other applications based on the remote sensing or photogrammetry. We can use this kind of technologies for mapping, something like topographic maps or cadastral maps or the automodec. We also can use this kind of technologies for 3D modeling to get the digital terrain model, digital service model, or 3D city models or 3D point cloud. There are also other specialized applications, something like medicine, cultural, heritage, or other applications. Let me talk about the structure for motion. The structure for motion is the method for creating the 3D model of a feature or topography from the overlap into 2D photographs. Structure from motion use the different camera locations to create the 3D world and sense. Yeah, so this is very important. The technologies to get the 3D model by using the 2D image. Let me compare the traditional stereo photogrammetry and structure for motion. To create 3D world, there are two methods. One is traditional stereo photogrammetry. The other one is structure for motion. For this one, there are many constraints here. It requires a stable platform, such as the satellite or airplane at the fixed elevation. And it photographs collected at the known positions with the fixed orientation and the heading angles. So there are many constraints here. But for structure for motion, it is relatively flexible and more benefits. It photos from the many angles and the distance can be used and enables the unstructured image acquisition from the ground and the manned platform. So it's the reason why we use the structure for motion technologies here. Here's the structure for motion 3D construction steps. Once we get the image, we get the key point extraction, bundle adjustment, and the point cloud generation. And then we check we get the point cloud densification and output point cloud. After that, we get the digital surface model and the auto mosaic. Here is steps of the structure for motion: get image, get the key point generation, key point matching, and the bundle adjustment. Yeah, in order to get the auto mosaic, we need to know how to get the key point generation. The key point is a characteristics point found in an image. It can be corner, intersections, and point. What makes a good key point? It should be distinctive, stable, good accuracy, invariant to the transformation, robust, and efficient. So as you can see, the picture shows here, no matter how you change the angle or size of the two images, you still can find the corresponding key points on each image. This is the good example, simple example of the implementing the key point generation on Pix4D software. For example, these pictures are all the pictures we obtained during the flight. In these pictures, the red car can be observed at the same time. We need to manually select the key point, such as the corner area of the front car here. And then these few pictures will use the same selected key point for picture stitching. Then we need to find more key points, as shown in the picture here, and we added several key points in order to get the huge image. We call this huge image as the image mosaic. This image shows the result of the point clouds. From the long distance from far away to the ground, we can see that we have successfully generated a point cloud to represent the objects on the ground, such as soil, vehicle, and crops. However, when we see the right picture, that when we observe the object more closely, we can find that the point clouds of some objects are not dense. And according to different applications, the requirements for density of the point clouds are different. And in the process of generating the point cloud, it is essential to set up the ground control point. The ground control point are the fundamental tools in GIS and the surveying. Sometimes the ground control points are not needed when surveying the result only for relative accuracy. So also we can see that we have to use five ground control points at least. More importantly, we need to ensure that the GCP is kept clean during the UAV flight, which will have a great impact on the final result. If the key points are not well found, or your GCP effect is not good, then the quality of the final point cloud you generate will also be decreased. Just like this picture shows a black hole in the middle, which cannot represent the good growth status of the crops. And let me skip that. This is the phenotype that use the structure for motion and the LiDAR to express the sorghum crops. It can be found that the LiDAR can express plant phenotypes more accurately than the structure for motion. But the LiDAR is more expensive than the camera, so it's hard to say which one must be used. If you are looking for the high accuracy of your measurements, then maybe the LiDAR is the good choice. And this is a good example of the agricultural applications. We can see that the picture on the left is the 3D point cloud of farmland obtained from the structure for motion technology after the flying to UAV. From this big picture, we can find that the point cloud near the brown color represents the high altitude, and the point color near the green or blue, it represents the low altitude. So in this way, we can get the height information. As you can see, the height information of the crops are shown here. The plant height obtained on May is still relatively low, but the data on June and July, we can see that the plant is higher than the before, which has helped us to observe the growth status of the plant. And actually, the Pix40 mapper is our most commonly used software. So it can be used for generating the point cloud and the auto mosaic. As you can see, the prices of the commercial one and educational one are shown here. Oh, another mostly used software is called Agisoft Metashape, which can be also used for point cloud and auto mosaic generation. And as you can see, the price for commercial one and educational one are shown here. There are also some cloud-based solutions, such as Pix40 Cloud, Drone Deploy, and the Open Drone Map. Okay, so from this slide, I would like to briefly introduce about my research by using the UAV. The first topic of my research is autonomous mobile ground control point improves the accuracy of the agricultural remote sensing through the collaboration with the UAV. Let me briefly introduce about the ground control point. The ground control points are critical for the agricultural remote sensing that require the geographic registration, radiometric calibration, and height calibration when overlaying the images collected at different times. However, using for receiving high geometric accuracy, we need to use the real-time kinematic GPS or post-processing kinematic GPS. It should be spread across the ground area of the flight zone, and at least 5 GCPs are needed to maximize accuracy. As some of you may know already, one of the commercialized GCP is called aerial point GCP, which is reusable, portable, and it records the position data repeatedly during the UAV flight. And the multiple aerial points can be used to increase the accuracy of each flight. And the researchers use this GCP for agriculture and forestry remote sensing. But in our research, we proposed an autonomous mobile GCP. The autonomous mobile GCP was constructed as shown in this picture. The GCP platform consists of the robotics layer, control unit layer, and the reference layer. So the base layer consists of the motors, motor drivers, battery, something like that part. And the design of the base layer enables the differential speed steering control of the front wheels. And the control layer hosted the high-level control and the low-level control. You also can receive the RTK GPS signals. As you can see, the reference layer we have the, as you can see here, the black panel and the white panel. We use these two panels for radiometric calibration. As you can see, the two blue colors panels. The two blue colors panels, we use two panels for temperature calibration because one is heating panel, another one is cooling panel. Yeah. In order to automatically navigate the GCP during the flight, we developed autonomous tracking system. As you can see, once we get the desired path, it can operate the system by changing the steering angle based on the specific control model. And then the steering angle can be sent to the low-level controller to change the direction of the mobile GCP. And the look-ahead tracking method was used to steer the mobile GCP when we get the predetermined waypoint. Yeah, here's a video showing the collaboration between the UAV and the GCP. So actually, a collaboration strategy was proposed, and I would like to introduce a little bit. When the UAV fly close to the mobile GCP should be stopped, cannot be moved. Once the UAV flies far away from the mobile GCP should be moving forward to the next waypoint. Once the UAV flies back, the mobile GCP should be waiting for captured by the UAV. Once the UAV fly far away again, the mobile GCP start moving forward. So the process should be repeated in a cyclical manner throughout the flight. In order to validate the system, we firstly used conventional method. This is the conventional method. Most of the researchers are using the conventional calibration method. We use the four fixed GCP for georeferencing. We use the height information for the. We use this kind of multiple layer GCPs for height calibration. We also use this kind of the reference panels on the ground for radiometric calibration and temperature calibration. Yeah, let's see the proposed calibration method. This method is proposed in our study. We just use this mobile GCP for calibration. We use this proposed system for georeferencing, height calibration, radiometric, and temperature calibration at once. After that, we need to validate the test. So this is validation test. We use the 4 GCPs for georeferencing. We also use 2 boxes for height calibration, and use these different color panels for radiometric and temperature calibration. And this table compares the arrows in position, reflectance, height, and the temperature for the conventional method and the proposed method. Clearly see that our method is more accurate than the conventional method. And the second topic is the collaborative operation system of the autonomous unmanned aerial vehicles for field phenotyping in farm field. Actually, because the UAV use batteries as the main power source, so the flight time and work area are limited. As the battery capacity increased, the payload decreased. So the battery capacity cannot be increased continuously. And most of people just use one UAV to fly the field, but we proposed multiple UAV system. So it can work on more field at the same time than the single UAV. And because the status of the crops should be moved by wind, So maybe in this way, we cannot get the high accuracy of the 3D model if there's a disturbances, something like wind. In this way, we want to propose a collaborative UAV system to improve the monitoring accuracy. So as you can see, we use the 2 UAVs for autonomous driving. And here is the UAV system configuration. And for collaborative driving, a flight path must be created for each UAV. To create an optimized flight path for multiple UAV, several variables are required. The path created in this study as shown here. And as you can see, this is simulation of the flying. If you look at this video, we can see that autonomous driving along the path is followed by the cooperative driving algorithm. And here is a virtual environment, something like simulator. Before the flying in the real world, we have to check our system is good or not in the virtual environment. And the algorithm, the system was tested in our university. Yeah, as you can see, our result as a result of, as you can see, this is the simulation flight trajectory of the multiple UAVs, and this is the actual flight. The arrow, the position arrow, are pretty similar. So it means that our system the 2 UAVs can fly together simultaneously together and can get the good data here. But also, since we have to fly the UAV simultaneously, so we should have the collaborative algorithm when the UAV arrive the target point. So another UAV should be waiting for another UAV. Once the UAV arrive the target point, and then the 2 UAVs should start to fly again, targeting to the next point. Yeah, this is my last slide for my presentation. I would like to use this slide to finish my presentation. This is our final goal of the collaborative system. As you can see, here are 2 UAVs. The 2 UAVs should fly together. And here is the ground robot. The ground robot, we call this mobile GCP. And the image captured from the UAV should be transferred to the mobile GCP. And then the mobile GCP should upload the image to the satellite. And the satellite, we need to use cloud service, something like Amazon Web Service to do the machine learning or deep learning, that part, to get the description map. Once we get the description map, the farmers will know. Once we get the prediction map, it will send to the farmer. Then the farmer will know where the crops are damaged or the status of crops is not good. Then the exact position will be sent to the ground robot. The ground robot will get the command, get the mission, access to the specific area of the crops, damaged crops. Then the robot will take the image, capture the image, and do the fertilization or other process. So in conclusion, we have to develop the wireless network that connects all the multiple collaborative UAV or ground robots. We also need to establish a collaborative navigation system for the multiple UAVs and the robots, ground robots. And finally, we also need to use this kind of system to get the 3D information of the crops on the ground. Thank you. Thank you.
Okay, thank you so much, Dr. Han, for a nice and interesting lecture. I also have some notes from this presentation, especially about the development of UAV device for agricultural purpose, concept of photogrammetry in agriculture, and also some interesting achievement and publications about autonomous mobile research. Again, thank you so much to Dr. Han for the lecture, and let's give him applause or by clicking an emoticon button on your Zoom screen. Okay, thank you so much, Dr. Han. And guys, if you have any questions about this topic, you may write it down on the chat room to be answered by our guys lecture today. Okay, here we have actually some questions for the lecturer. Okay, the first questions I may read it for you. The first one is from Professor Lily from Universitas Gadjah Mada to Dr. Suchada. Thanks and nice presentations. Do you have any experience related to food traceability system in Thailand? And how about technology development in Thai food industry toward the era of industry revolution 4.0? Thanks a lot. Okay, maybe you can answer it to Dr. Suchada first. Thank you.
So I can explain right now.
Yes.
Okay. So basically, I have very small chance comparing to another department because we are in design and manufacturing department. We're just trying to make the concept, and another department we use our concept to continue in the real place. I mean, in the real factories. But recently in our program, we have logistics supply chain, and then we have a lot of opportunity to visit Ajinomoto company. Normally, they're trying to use the not directly to the food, but they're trying to do something about transportation for the food products, how to keep the food in a good place. Just like I show you some cold room. One of the students, Mr. Nak, he got a scholarship from Ajinomoto. He studied with me, and then he was assigned about how to design the cold room for saving tomato in a good place. Okay, so just only some part of that, but I did not got the fund or the, let's say, the project from the real industry. I just passed through from the student. Just like I got the assignment from the student who got a scholarship from some places, just like the indirect, let's say indirect like research. Normally for some company, they really want to know like RFID, how to attach, check the stock inventory, about the amount of things inside their inventory, just like to let them know about notifications in and out, and also attach something to the truck, let's say, for like prevent any losses during transportations. For the real like work, like go to the plant or farming, like primary industry, I did not get involved that much for that part. For more detail, I may write down the email or some description later, because I still have some team in my school who work with that kind of like process directly. Some of professor has some colleagues in another university, like Kasetsart University. They work with like more than 100% in agricultural like field. Okay, I will try to combine the information for you and trying to launch you later. But to me, myself, I just make only the concept, process design, or event to make the research, and somebody else may continue my work to another purpose else.
Okay, thank you so much, Dr. Suchada, for a nice answer. Okay, the next questions may be from Eko Widi, GM, Universitas Gadjah Mada. To Mr. Han, the question is how much it is cost to invest for drone system for traditional farmer and in a small scale industry until large industry. I think the question is related to if we implement the concept of UAV or mobile system to the real application in traditional farmer, how much it will cost.
Okay, thanks for your questions. Actually, this is the actually in my study, I'm doing the research about the collaboration system. Actually, this is the stage of the collaboration system is just beginning stage. I didn't see any other researchers doing the collaboration system in agriculture area. So since this is the beginning stage, we are still using the high cost sensors, high cost the actuators. So it's pretty difficult to decrease the price of the system. But if we are only focusing on the UAV system, there are lot of the UAV companies from the around the world. Most of the people, as far as I know, the hexacopters, something like or other UAVs is called the price is about $5,000, but that was developed by DJI. I'm not sure if you know the DJI companies. Yeah. But there are some other smaller, startup companies in China. The price pretty low. Only $500 to $10,000. So only focusing UAV, we don't need to pay pretty high cost for UAV. But if we are focusing on the collaboration system, I think this is still beginning stage. Yes. We need more time to do the development. Thank you.
Okay, thank you so much, Dr. Han, for the answer. Maybe in the next, in the future, we will see many things related to UAV for to use in the farming, I think. Okay, the next questions maybe from EcoVD, from BC company to Dr. Suchada. Could you give us some resource we can study, like website or YouTube channel that relate to IoT implementation for vegetable seed processing? I would like to gain for potato seed storage research. Please give us some advice related to IoT for the storage. Thanks.
Okay, so right now I'm trying to find some websites or event articles for you to ready. So maybe I will try to send you via email. Would be nice, or maybe I will pass to Dr. Mark Booth for transferring the information to you. Some I have found maybe about farming in different fields, like in the international journals, and another one maybe in like YouTube. It's easier to see. Okay, I will try to send you all of that. Thank you so much.
Okay, maybe we will send this information later to the participant via email or via email, because we have all the participant email in our database. Okay, let's move to the next questions from Muhammad Akbar from CNU. Question to Prof. Han. Can we make a deep learning model algorithms? For example, the algorithms for automatically measuring the crop height using photogrammetry method, since the accuracy is not as good as if we use LiDAR. Thank you.
Okay, thanks for your questions. Yeah, I think it's a good question. Actually, measuring the crop height is is pretty not easy. It's very complicated because in order to get the high accuracy of the height measurements, we need to have a good calibration system on the ground. That is the most important things to get the accurate measurements. But I didn't see any researchers who are focusing on the height measurement based on the deep learning model. Yeah, I think this is a good way to do, and most of people, researchers use deep learning model just for the crop disease or called pest or disease, something like that application. Or I didn't see any method for measuring the crop height based on the deep learning model. I would say if you want to improve the accuracy of the crop, improve the accuracy of the height measurements, you have to develop the good quality of the height calibration system on the ground. That is important because the height information should be can be measured by the camera or LiDAR. But as the data shown in my presentation slide, the LiDAR accuracy is more accurate than the photogrammetry method. But most of people just think the LiDAR, the algorithm from the LiDAR by using LiDAR is more difficult or more complicated than the photometry. So that is the more difficult things for most researchers. But sorry about that. I cannot give any good answers for this question. But I would say the ground calibration system is the most important thing here. Yeah.
Okay, thank you so much, Professor Han, for the answer. Okay, actually we still have 9 minutes left for this discussion. If you have any questions left, feel free to open your microphone to ask directly to our guest lecture today. Okay, anyone? Okay, Professor Han, we used to use the UAV for what land mapping, like land mapping or farm mapping in our projects. But sometimes the high wind conditions is very make us very difficult to grab the good image and to process it in to make the good map for the farming. Is there any recommendations for to correct this issue or to give the solution for this issue?
So your question is that you want to get the high quality of the image, right?
Yeah.
Yeah, it depends on your application. I'm not sure what kind of camera you are using. Actually, the most camera used by the most of researchers is the MegaSense camera. MegaSense camera is a multi-spectral camera. It has a good resolution. It can get the high resolution of the crops. So first of all, you have to get the stable posture or attitude of the camera. In this way, in order to get the stable balancing of the camera, you have to put the gimbal on the UAV. Since the gimbal has a gyroscope or IMU sensor, it can keep the balancing of the camera, even though there is a heavy wind, or other disturbances from the outside. It can keep the good balancing of the camera to let you get the high quality of the image. Yeah, this is the important things on the UAV. But another things, as I mentioned again, the calibration system on the ground. If you want to get the exact height, if you want to get the exact information on the ground, the ground calibration system is very important to let you calibrate your image. So I think these are two important things here.
Okay, thank you so much, Dr. Han. And this maybe the last questions from Prihat Maka. For Prihat Maka, can you open your microphone to ask directly to our guest lecture today? Can you?
Is it?
Actually, yes.
For me or Dr. Suchada?
Maybe for both, for both Dr. Suchada and Professor Han. The question is, I want to know that in your opinion, the cost comparisons with or without the application of its technology, more costly but efficient, or more cheap but with the abundant product, it makes the price will decrease. I think the question is the efficiency of the use of this kind of technology. For example, the technology that Professor Han has talked about, or from the presentation of Dr. Suchada. Can this technology make the price of the final products decrease, or the quality of the product can be improved? Okay, maybe Dr. Han or Dr. Suchada first.
Dr. Suchada first.
Yes.
Okay, thank you so much.
Ladies.
Okay, so in my opinion, since I work with the undergrad student plus grad student, so they have different experiences. One thing that I would like to use is about technology that applied is quite simple but interesting. We're trying to make everything like DIY concepts. We have to bring everything around you to make things new, like told you before. So the price of my device or equipment just less than maybe $1,000, something like that. But we can make a very big view for the systems. For example, just like watering automatic filling machine. You're trying to bring perception of the customer. They say that from my experience, I found that my parents always ask me to fill the water and put it, I have to wait for long, and the water spillage a lot. So in my opinion, when I graduate, I really want to do something like advanced technology in case that SME scale, small and medium scale enterprise. I would like to produce like small business of mine based on my lazy day in the old day. I'm trying to bring just like traditional filling machine, you have to wait and fill, right? But right now I would like to add some extraordinary thing to that place. So we just modify something from things around you, let's say like that. So the price of my technology is not that high comparing to the one that you bought from the market directly. So we call like product design and development concepts. With and without, for sure, we try to make our life easier and better. So it should be better. And the redundant is about, yes, we're trying to use the concept of product design. The redundant here is mean we're trying to find the existing design in the market. We're trying to remodify them, try to bring the benefit of each, but with limited costs. Since the budget for the senior project in my school, I think it's around, let's say around $1,000 US dollars, I think, for each group. So we're trying to create every project within this limited like amount. So even this year, the senior project of mine, they are work with the smart garden. They're trying to make everything in condominium one or the apartments, because the students stay at home in the dormitory or even in the house that have limited space. So we're trying to make small scale, like COVID time, they want to earn some money too. So what to do? We're trying to support students, what they really want to do. This is the reason that I trying to tell you that the cost that I mentioned here is not that much, but the quality of my prototype is not that high comparing to the commercial one, because it is in-house design. We can use everything that already have in our house to make it happen. This is the concept of mine. I'm not sure that my question will support your question or not, but in case that you want to know about the cost and the price of the finished goods, maybe I cannot say because my product is the prototype one. Okay, thank you so much.
Okay, thank you so much for your opinion, Dr. Suchada. And next, maybe we need to hear the opinion from Professor Han. Feel free.
Yeah, I'm pretty agree with the Dr. Suchada. Actually, I think if we want to get the high performance of the system with the low cost, we need to use the sensor fusion technology. So something like a sensor fusion technology, which requires us to develop the algorithm for fusion. So let me use the GPS as an example. In our lab, we are doing the GPS fusion technology in order to actually the GPS the price of the GPS is pretty high. It's pretty expensive in the past, but nowadays the GPS price is pretty low. Even if it is cheap, but when the signal is blocked by the cloud or buildings, the signal gets weak, so we cannot get the high accuracy of the signal. In this way, if we use the high price of the GPS, yeah, you can get the good signal, good result. But if you want to use the low cost of the units or devices, then you need to develop the sensor fusion technology, something like the DIY system, as mentioned by the Strada. So yeah, this system is still the prototype system in our lab, and anyway, the algorithm method is the most important thing if you want to decrease the price of the hardware part. Yeah, that's it.
Okay, thank you so much from Dr. Han, also Dr. Suchada. Because our time is up, again, I would say thank you so much for your insightful lecture. We hope this is not the last, and we can collaborate in the next opportunity or in next time, or maybe we can invite you to visit our department after the pandemic physically. Okay. Yeah. Okay, thank you so much.
Thank you
to Dr. Suchada and Professor Han. Okay, before I finish this, okay, maybe I will return the stage to Miss Bella as the MC. Thank you.
Thank you so much.
Okay, thank you to Mr. Makbul who has led the discussion this afternoon. Once again, thank you to Dr. Sukadarian Mora and Professor Han who have presented the lesson. Before closing this event, we ask for a moment for a photo session because it is requested for all participants to activate the video. Sebelum menutup acara, kami meminta waktunya sebentar sesi foto bersama. Karena itu dimohon untuk seluruh peserta mengaktifkan video. Okay, maybe I'll take a picture. Slide 1. 1, 2, 3. Next, slide 2. 1, 2, 3. And then slide 3. 1, 2. Okay, thank you to the participants who have attended this guest lecture until the end of this event. It is reminded again for all participants to fill the presents that has been shared in the chat column, because we only distribute certificates to participants who have filled out the attendance list. Further information can be accessed on our social media. On behalf of the Committee on Jadi, I apologize if there are many wrong words and actions. Thank you for your attention and participation in today's event. Don't forget to follow our social media account to see more upcoming events. Instagram at tpb.ugm, Facebook or Twitter at tpbugm. Wassalamualaikum warahmatullahi wabarakatuh.